Hi everyone, my name is Thomas and I am a third year astrophysics student studying in Scotland, and welcome to my channel, Inversion Science, where I talk about everything physics, astronomy, academics and everything else science. Now recently my family and I went on a road trip around the North Coast 500 in Scotland, and on the way we stopped off at Fort William near Ben Nevis. Now in the Nevis Range there is a mountain gondola that can take you up the mountains without having to climb them, and you get a lot of nice views. And when I was at the top, I bought a plastic water bottle. Don't worry, I recycled it. But before I did, I came back down the mountain and got this picture. Now, what had been a normal Strathmore water bottle had, in the time it took us to come down the mountain, been squashed. But how? How did a mountain crush my water bottle? Okay, so the mountain didn't crush my water bottle, although to be fair, if you dropped a mountain on a plastic water bottle, I wouldn't put much money on the water bottle being okay. What did crush the water bottle was actually the atmosphere. And I know that sounds kind of strange. I mean, we move through the atmosphere with relative ease, but coming down a mountain crushed a water bottle? Well, the reason that happened is because everywhere on Earth there is this thing called atmospheric pressure. A pressure exerted on objects in the atmosphere by the atmosphere itself. Atmospheric pressure is a thing that exists anywhere there is an atmosphere. Mars doesn't have much atmosphere. Its atmospheric pressure is much lower than that on Earth. In fact, wind speeds that would be gale force here would be a light breeze on Mars. Jupiter, on the other hand, has a much higher atmospheric pressure. If you stepped out of a spaceship in Jupiter's atmosphere, you'd be crushed to the size of a ping pong ball. But what is atmospheric pressure and why do we have it? Well, the reason we have atmospheric pressure is because the atmosphere is made up of gas, but gas particles, well, they don't sit still. Gas particles, like everything else, have temperature, which means that they have some kinetic energy, which means they sort of buzz about all over the place. They crash into things, such as each other, or cars, or people, or, yes, water bottles. When they bump into things, they exert a force, which, when you spread out over an area, is a pressure. But all of this doesn't explain how my water bottle got crushed. Well, for that, we have to talk about how atmospheric pressure varies. The reason we have an atmosphere is gravity. When the Earth formed, it grabbed onto a load of gas because of its gravity that has evolved with the planet to the current mix of nitrogen, oxygen and some other gases such as argon and carbon dioxide. But you'll probably know that gravity gets weaker the further away you are from the Earth, which means the force on the atmosphere the further away you go is weaker. Because there is less holding onto these molecules, it's easier for them to escape. Now, you can actually determine the difference in atmospheric pressure at different heights above sea level using this equation, where Z is the height above sea level in meters. So the base station is 100 meters above sea level, and the top of the gondola is 550 meters above that. So we can actually see that there's a decrease in pressure as you go higher. It decreases by about 6% of the pressure we have at sea level. But this still doesn't explain how my water bottle got crushed. The reason my water bottle got crushed is that I opened it at the top and drank from it. When I drank water from the bottle, it created empty space inside the bottle, where air from the top of the mountain was able to get in. Now, at the top of the mountain, there was this low pressure air inside the bottle and outside the bottle. So the pressure on both sides was the same. But before I came down the mountain, I closed the water bottle and sealed it. Now, the seal wasn't perfect, because nothing ever is, but it was very close to perfect. Not much air could get in or out. So as we came down the mountain and the pressure rose, the pressure outside the bottle became higher than the pressure inside the bottle. What this means is that there was more force in than out. Now, because of this pressure imbalance, the pressure on the outside, the higher pressure, won out. It began to compress the bottle until the volume inside the bottle was actually small enough so that the pressure equaled that of the outside. Although, to be fair, it may have been stopped by the structural integrity of the bottle. It's kind of hard to say. I don't have the bottle now to run tests on that. I'm not even sure how I would run tests on that. But assuming that it wasn't structural integrity that stopped the compression, then that means that it was the equalization of pressure inside and outside due to the compression that led to the bottle stopping compression. So that's how a mountain, or more accurately, the atmosphere, crushed my water bottle. If you like this format of me talking about things that I've actually experienced in the world, then please hit a like on this video and leave a comment letting me know what you liked. If you have any questions, criticisms, or questions you'd like answered in future videos, then please leave them in the comment section below as well. If you'd like to do a bit more reading about atmospheric pressure and the sources I used for this video, then please check out the link in the description below. In the meantime, please like, subscribe, and I'll see you in the next video.